So Mike gave us a great tour of the CLI, the command line interface. Let's take that just a little bit further and talk about the various types of shells. So one of the shells that we have to be aware of, or one of the command line environments, of course, is the Windows command line. Mike took us through a couple of commands. We'll expand on that a little bit later and look at some further Windows command line tools that can help you troubleshoot problems and also detect suspicious activity. We're also going to take a look at Microsoft PowerShell in a bit more detail. We're going to talk about Linux shells in a bit more detail and work with command lines within Linux. And we're also going to take a look at Python. Now, most people don't consider Python necessarily to be a shell. Python is normally used as a scripting language or to write some server-side code perhaps that'll run on a web server. However, Python does have its own shell. For example, in Linux, if the Python environment is installed, you can just type in Python and you're in a Python shell where the commands you issue are specific to Python only. You're no longer in a regular Linux shell. So what's the benefit of all these shells and typing things in at the command line? Because it seems like an awful lot of work. There's always a benefit. The benefit is that if you can type something in, that means you can script it. You can create a script file, which in turn means you can automate repetitive tasks that you perform on a periodic basis. You might write a script, for example, that contains a bunch of PowerShell commandlets to force updates on computers, maybe to take an inventory of what kind of hardware you have in your computers. It can do that by reaching out over the network. You can even schedule it using the Windows Task Scheduler. That's a lot easier than manually remoting to every computer on the network to get some hardware details and forcing updates. So scripting is a very important aspect of being a benefit of working with shells. Now we could take that a step further by also talking about reverse shells. What's a reverse shell? Well, generally speaking, a reverse shell means that an attacker has gained remote access to a shell by coming into your machine, reverse. So how does this work? Well, what happens is we can use tools like Netcat. Netcat is a freely available tool that you can download and run. The command line is simply NC for Netcat. So we could run Netcat on an attacker station, that would be the malicious user station, where we might load it up and listen on a port that we want to allow connections from a victim machine. So in this case, we're loading up a listener on port 443. Now that's a good choice from an attacker's perspective because if we switch over to the victim computer, somehow the victim is going to be tricked into executing the Netcat program, nc.exe. Now how will we do that? Well, maybe through a phishing email scam that looks legitimate and somehow we trick the user into downloading or running that. So there are many ways that that can be done. Now the idea is that when it runs on the victim station, when Netcat runs, it would point to the IP address of the attacker station. And then what we could do is say that what we want to do is run a shell. Now, what's happening is the victim's machine is where the shell is running, but we're making it available on the attacker system over the network. And remember I said port 443 was a good choice? From the intrusion detection standpoint on the victim network, all that it looks like is happening is that victim computer is going out somewhere on the internet to port 443, which is normal for secured websites, HTTPS websites. Now, if you're thinking, well, my virus scanner is going to pick this up, well, you're right, it will. But if you at all have any knowledge of computer programming, software development, it is very quick and very easy to write your own reverse shell listener and also your own client victim tool. So they talk together. Very easy to write code to do this, and there are plenty of books that tell you how to do it. For example, here on my computer, I've opened up my Kindle app where I have a lot of ebooks that I have purchased and that I read. And notice some of the titles I've got here. Port Exploitation with Metasploit, Hack and Detect, Advanced Penetration Testing, Hands-on Hacking, Great Light Reading. The idea is that with these kinds of books, you can learn very easily how to write your own listener that can evade malware detection. So this is something that we need to be aware of. And more importantly, our end users need to be aware of how scary it can be in a shell environment if users aren't aware that they shouldn't be clicking on things they didn't ask for, such as through a phishing email message. Now, in the case of a reverse shell, this can serve as an advanced persistent threat, an APT, All that means is that an attacker has a way into the system over and over and over again over time. They might even install some other way to get in, which is called a backdoor, maybe by creating another user account that looks legitimate but is completely under the control of the malicious user. So we know that we've got tools for reverse shells like Netcat. We know that we might even be able to build our own if we have an interest in programming a little bit. But there are other penetration testing tools out there that exploit vulnerabilities that have this kind of stuff built in. Things like the Metasploit framework, things like Cobalt Strike. These are all tools that are used by pen testers to try to exploit vulnerabilities and try to run things like reverse shells. So we've got standard shells for legitimate use, like Windows command line, Linux bash shell prompts, for example, PowerShell, Python, and then we've got the more nefarious reverse shells used by malicious actors.